The global market for glass and carbon fiber composites is robust and growing, driven by their application in key sectors like aerospace, automotive, construction, and wind energy. While the overall composites market was valued at approximately $115 billion in 2023, forecasts project significant growth, with some reports estimating a valuation of over $200 billion by the end of the decade. 3 easiest and most budget-friendly techniques are summarized for consideration. Hand layup, resin transfer molding, and vacuum bagging, also known as vacuum resin infusion manufacturing techniques, are versatile and cost-effective methods for manufacturing fiberglass items. This presentation briefly compares the advantages and possible applications of these relatively low-budget fiberglass manufacturing techniques for composites products required in daily use and for specialized high-end items. This process is suitable for small production runs and prototyping, and requires minimal equipment compared to closed mold methods. Allows for complex shapes and sizes, which include lightweight but strong building panels, tanks, and decorative architectural elements. In addition to these, custom housings, covers, and other large components can be easily produced. Other products, especially in residential and leisure industry, comprise of shower trays, vanity sinks, and components for caravans and motorhomes. Hand layup has been widely used for many years. It has simple principles of process and has lower costs. One has the option to choose ingredients and equipment from a wide variety of suppliers and material types. Hand layup process can produce higher fiber contents and longer fibers as compared with spray layup. The table in the slide shows significant aspects of hand layup process. Vacuum-assisted resin transfer molding, VARM, requires a single tool surface. This tool could be as simple as a waxed glass surface, or as complex as a machined mold. Instead of using a second mold on top of the layers of carbon or glass fiber, a vacuum is applied over the part and resin is pulled across the part with the same vacuum that is holding it under pressure. This process can be completed in anyone's garage with just $300 worth of equipment. It is a good process for larger or lower volume parts, and produces parts with a smooth but not finished beside surface. Reusable bags are faster and easier to use, as well as reducing the waste process materials that come with disposable bag infusion. Generally, this is usually done with polyester or vinyl ester resins. Epoxy does not allow ease of reuse for vacuum bags as it is hard on silicone bags. Current screen displays pros and cons of VARM process. VARM allows products with higher fiber content laminates. Furthermore, lower void contents are achieved than with wet layup. This technique gives better fiber wet out due to pressure and resin flow throughout structural fibers. In terms of health and safety, vacuum bag reduces the amount of volatiles emitted during cure. Resin transfer molding, RTM, is the traditional process of creating a resin-infused part. Involves shaping a material, typically a thermoset or thermoplastic composite, by placing it in a heated mold cavity, compressing it under high pressure, and then curing or cooling it to form a finished part. RTM requires a top and bottom mold, with the layers of carbon or glass fiber sandwiched in between, much like a compression-molded plastic part. Resin, or plastic, is injected into this closed mold to fill the entire space while under pressure. It is excellent for structural components, and ideal for medium to high production volumes with low material waste. RTM works with both thermosets and thermoplastics. RTM can produce parts with intricate geometries. High fiber volume laminates can be obtained with very low void contents through RTM. Both sides of the component have a molded, finished surface. Educated and well-trained labor must be employed for facilities that produce parts through RTM, as it involves use of softwares and complex manufacturing setups. It has good health, safety, and environmental control due to enclosure of resin. We hope this walkthrough has provided some valuable insight, and that you will be able to start infusing your own parts soon. Previous experience with carbon fiber and fiberglass will allow ease of using resin infusion. Let us step into the world of fiberglass and start producing products using one of the basic composites manufacturing techniques.